Hello everyone, my name is Avin, and today I'll be showing you how do you take your scikit model and put it into Kubernetes cluster for a deployment in just a few minutes. So traditionally, once you have your model trained, you would probably put it in somewhere like in a Flask and in a Docker container, and to put this into a Kubernetes cluster is a relatively complicated task. You would require some amount of DevOps knowledge, and from there it takes a few days of this configuration. But we'll be using Panini AI that will simplify a lot of these things for us. So all we'll be doing is we'll be training our model, taking our trained model, and we'll be putting it into Panini AI. And Panini AI will just take care of putting into a Docker container for us, putting into Kubernetes cluster. It will handle things like batching and caching and load balancing. So our entire thing will be production ready. So let's begin. So over here is my Jupyter notebook, and today we'll be just working with the iris dataset. So this iris dataset is a dataset of 3 different categories of flowers. So you have these 4 different features, these 4 different numbers, and depending on that, if the flower falls into 3 different categories. These are the 3 different categories, right? So the model set, it's very famous. You can just download it from over here, and most likely you've also used this model in the past. So let's begin. So first, let's train the model. So in order to train the model, we'll have a scikit-learn. Oh, before we begin, very important that you do have Python 3.6 installed, okay? In order to use Panini, you do need Python 3.6. So make sure you have a Python 3.6 installed in your environment and have a scikit-learn, sklearn installed. Now, just import my sklearn, and over here I'm just downloading the iris dataset, and I'm just placing my all of my features into X and my target prediction value into Y, and we'll be just using a logistic regression. And over here I'm training my model, right? So I'm just fitting it. So this over here is just training the model. Ideally, in a real-world environment, once you have your data set, you would most likely would want to split your data into 80-20, into train and test set, and so on. But just for the sake of this demonstration, we'll just train the entire thing. Now, once the model is trained, we'll be saving the model, and this is what's happening right over here. In order to save the model, we'll be just using Python pickle. So over here, I'm just saying that I want to write a file called model.pkl and pickle.dump, and I'm going to specify the model that I want to save. In this case, it's right over here. That's a reference. And the file that I want to write it in is an out file, and I'm going to close it. Okay, so over here, I just saved my trained model. Now, this line over here, these lines, they're just for me to make sure that everything got saved into my hard drive properly. So the model that I saved over here, I'm just reloading that model back again, and I'm just printing it out. And for sure, I can see that it printed out, just for me to make sure that everything was saved properly, okay? Now, we have our model trained. Now we want to take this trained model and put it into Kubernetes cluster, okay? So we're going to put this in a Panini. So now, if you want to put your model into Panini, you need 3 different things, okay, at the very least. So 3 things that you need is, first thing that you need is predict.py. The next thing that you need is requirements.txt. Then after that, the very third thing that you need is your model.pkl. This is the model that we saved, okay? Now, Panini, inside your predict.py that I was telling you about, this right over here, there has to be a function called predict, okay? So make sure that the function has to be named exactly predict, and it looks something like this. And inside this predict, that's a function that gets executed every single time a user pings that user sends a post request to our API. So when we upload our model into Panini, Panini will give us back with this a URL, and later on we can simply send a post request to that URL, and we can infer our model. So every single time we send a post request, this predict function gets executed. And the data that we send, so in our case, that these are the features of a flower, would be saved over here, input from user, okay? The next file that we need is requirements.txt. That's just your plain old requirement file that has all of your pip packages. So in our case, since we're using scikit-learn, all we need to do is create a file called requirements.txt and have scikit-learn. You don't really need NumPy. I don't think we're using NumPy in this example, but if there's a project where you have NumPy, you can just install NumPy. So yeah, just like your normal requirements.txt, okay? And of course, the third file that you need is model.pkl, okay? So once I have those 3 files, I'm good to go. So let me just show you how it looks like. This is my setup over here. So This right over here is my requirements.txt. I just have scikit-learn and numpy, that's it. Then after that, I have my predict file, okay, predict.py that I was telling you earlier. So in predict.py, it's very important that I have this function called predict inside my predict.py, okay? I can have other functions too, doesn't really matter, but I need to have predict function. Inside this predict function, this is the function that gets executed whenever a user sends a post request to my API, right? So what I'm doing over here is that I'm just loading up my model, that model.pkl, this right over here that I saved earlier, this right here. Okay, in order to load the model, I just wrote another function called load, and over here I'm just literally just reading back the model and loading it back up over here again. I don't really need this function over here called load. To be honest with you, I could have just copied this and put it right inside here. I just decided to have another function called load. It doesn't really matter. I can call this load model, I can call this function whatever I want. All this function over here is doing is that it takes a path, it loads up the model, then it returns a reference to that model, okay, right over here. Then after that, once that happens, I'm going to take model.predict and input from client. So the data that we send that gets executed is coming from right over here, input from client, okay? So in our case, we're sending these 4 different float values, and that's coming right over here, input from client. We're passing that data that the client sent into our model, okay? Now, we have a prediction, and this prediction is usually if it's a 0 or if it's a 1 or a 2. Okay, if it's a 0, it's this. If it's a 1, it's this flower. If it's a 2, it's this flower. All I'm doing over here is have a for loop, and users can send more than one sets of prediction. So that's why I'm just having an array, and in the end, depending on what it is, I'm just sending the value back. Very, very straightforward, okay? Just do make sure that when you are returning a value, it has to be an array. Even though you're only returning, let's say, one value, let's say you're only returning one value and that value is a string called satosa, that satosa needs to be in an array, in a list, and it has to be just one element, okay? So just make sure that the return value has to be a list, that's all. Now, I have this, I have a requirements.txt, then I have a model.pickle that I pickled. Now I'm ready to go and upload it into Panini for production. So I'm just going to go to panini.ai and click on login. I've already signed in, but if it's your first time signing in, it's going to ask you to sign in through GitHub or Google. Now it will come into this dashboard, okay? So in this dashboard over here, first thing that I need you to do is give my model a name. So the model name has to be less than 10 characters, A to Z, 0 to 9. Okay, so let's just call our my iris. Okay, for the framework, we have 3 frameworks available right now: PyTorch, Python Function, FastAI. PyTorch is if you're using any sort of deep learning. Python is if you're using SciKit-Learn, like SparkML or anything like that, like any sort of your classical machine learning, like SVM, random forest, and so on. And if you're using FastAI library, we do support FastAI library too. So let's just go ahead, select Python function. For input type, we'll be choosing floats, since this is a float as an input type. Then let's go ahead and click on browse. Now, in the browse, we're going to upload 3 different files, okay? Model.pkl, that's our saved model. Predict.py, that's a file, that script that I showed you earlier, which has a predict function inside, and requirements.txt. You're going to press choose. Now, this bottom one over here, you don't need to upload anything over here. This is for if you have more additional files, then you would upload it over here. But in our case, we don't really have any sort of additional files, so we don't really need to upload anything, okay? Now, once you select those 3 files, go ahead and click on deploy. Now, when you click on deploy and this 100% shows up all the way to the full on 100%, you can go ahead and refresh the page now, okay? So in my case, I'm just going to go ahead and refresh the page. When I refresh the page, you'll see over here, this new log will get populated. And over here, it's creating a Docker container for me. It said over here that, okay, your application was successfully registered, building your model, please wait a few minutes. So it created a Docker container right over here for us. It tagged that Docker container, and it's creating a model. It's saying that pushing your model image to Kubernetes cluster. So it's now pushing it to Kubernetes cluster. And let's just wait a few more minutes. Usually it does not take more than 2 or 3 minutes. And a API key should come over here. And when we have that API key, we know we're good to go and we can start inferring our model. So let's just wait a few more minutes, and we should get an API key relatively soon. And yeah, so sometimes if the log is not showing up again, then, oh, there you go. Yeah, it just gave us the API key. The very last message that you should see is done deploying your model, you're good to go, okay? And when you see this message, a API key URL will automatically show up over here. And this over here is a URL that you'll be using to make your prediction. All you need to do is send a post request in this URL. So let's try that. Let's go back to our Jupyter Notebook. And all we're going to do is we're just going to use a Python request package. This request package allows me to just send a post request. I can just use JavaScript in my front end, Node.js, Angular, or from my mobile app, whatever it may be. Okay, so let me just go ahead and replace this right over here. This is the data that I want to send, which is 5.1, 3.5, 1.4, 0.2. Okay, and I want my model to classify what kind of flower it is given these values. Okay. I'm going to send this API link, the data that I want to send, right over here, and press send. And bam, it replied back to us. The output, Setosa. So this flower over here, based on this feature, is Setosa. Now let me do it again one more time. Notice how the second time it was a lot faster, and the reason for that is, like I said, we do all these things like caching and batching for you already in the background, so if an input already showed up in the past, that entire thing wouldn't be recalculated again. It's saved into our cached memory, so if we know that, okay, 5.1, 3.5, 1.4, 0.2 was already sent, our model already knows the answer for that is Setosa, and it will automatically send that back to you. So we take care of all this batching and complicated stuff for you, and we also do load balancing. So yeah, you can also use something like Postman, for example. Here's an example of Postman that I did earlier, and just send a post request to this API link and give me back the flower category. And yeah, that's pretty much it. So I hope you found this tutorial helpful. And if you have any further questions, just do send me an email, and I'll be more than happy to help you out with your model deployment. And yeah, thanks a lot for watching this video.